Alright, welcome to the next section, second half of exponent rules. In this one we're going to learn all the division properties. So last section we learned multiplication and powers of powers. Here we're going to learn the division property with negative exponents. So no new vocab, but lots of new exponent rules. So first one is the quotient rule. Anytime you're dividing something. So if you divide two monomials, here's our first monomial, here's our second monomial. You divide the coefficients, a over b, gives you a new number, a over b. You keep the base the same, okay, and you subtract the exponents. So this is absolutely key, is that this base and this base do not cancel out. You keep the base the same, whatever it was stays the same. You do subtract the two exponents to get the new exponent. So for example, 5x to the fifth over 2x squared. Okay, 5 divided by 2 can't reduce, so you leave that as 5 halves. X to the fifth over x squared, you subtract the exponent. 5 minus 2 is 3. Okay, so sometimes students are tempted to cancel out this base and this base. The reason that's not correct is because x to the fifth literally means x times x times x times x 5 times, and in the denominator x squared literally means x times x. Now, you can cancel these out. The first two cancel out. However, there's 3 more x's left over in the numerator. So you can't cancel the entire base. You can only cancel 2 of them, leaving behind 3 more. So that's why this makes sense. Okay, zero exponent rules. Any non-zero number raised to the 0 power equals 1. So as long as the part in here itself is not 0, then this rule applies. And you don't have to worry about how complicated the stuff inside is. As long as you see a 0 exponent, you know the answer is going to be 1. A lot of students ask, well, why is this the case? And the best thing I can explain is by making a little pattern for you. For example, 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. Okay? And you can see that 3 is the same as 3 times 1, and 9 is the same as 3 times 3 times 1, and 27 is the same as 3 times 3 times 3 times 1. And so 3 to the 0 power, if you're looking at this pattern, the exponent tells you how many times you have multiplied by 3, right? But if you don't multiply by 3 at all, you still have this 1 that's left over. And you say, well, why don't I have a 0 left over? If you put a 0 right here, then you'd have to put a 0 right here, and 0 times 3 would just be 0. If you put a 0 here, basically you're saying everything would be 0. So when multiplying, the number that you can multiply without changing it is multiplying by 1. So when you have a 0 exponent, it means I'm not multiplying by 3 at all, so I just have the same thing that I have. That's the same as multiplying by 1. So 5 times 3 to the 0, how many times did I multiply by 3? I didn't multiply by 3 at all, so that's the same as 5 times 1, because we don't want it to change. If this right here was a 0, then it wouldn't make any sense, because 5 times 0 is 0, and we don't want to, by not multiplying by a 3, we don't want to change the answer. We want to keep it as a 5, keep it as a 5. Alright, moving right along. How about negative exponents? So a negative exponent means to take the reciprocal of the variable. The variable is the piece that has the negative exponent, but don't change the coefficient. So if you have a coefficient a, it stays in the numerator, but the variable part, that means the base and the exponent, you take the reciprocal and then you make it positive. So I like to think of this as almost like a battlefield, and anytime you have a negative exponent, it means you're on the wrong side of the battlefield and you need to move to the correct side. So x to the negative n moves into the denominator as x to the positive n. And likewise, if you have a piece with a negative exponent in the denominator, it has to move up into the numerator. But again, remember, any numbers in the numerator stay in the numerator, and any numbers in the denominator stay in the denominator. It's only the part that has a negative exponent that flips up to the other side. Okay, I want to show you a quick proof or idea of why this works so that it makes more sense to you. Remember, we learned the division rule, x to the n over x to the m equals x to the n minus m. So now imagine you have x squared over x to the fifth. according to this rule, we subtract the bottom from the top. So that would be x to the 2 minus 5, which would be x to the negative 3. Okay? However, by thinking of this as x times x over x, we can cancel out the first two. Remember, there's always a 1 right here. This is 1 over x third. There's the bottom wins by 3 is the way that I like to think of these as a fight. You've got 2 in the top and 5 in the bottom. The bottom wins by 3. So we have 1 over x to the third. And so these two have to be the same thing. After all, a math problem, when done correctly, only has one right answer. And so x to the negative third and 1 divided by x cubed have to be the same. So when you have a negative exponent, reciprocate it or flip it to the other side of the fraction, and then change the exponent. Okay, a couple problem solving tips, and we'll do some examples. It's often useful to start, like I just said, by flipping anything with a negative exponent. So when you're following PEMDAS, as long as all you have is multiplication and division of exponential terms, you can move anything that's in the denominator with a negative exponent into the numerator and vice versa. And the second thing is I want you to show all of your work. Show each step until you get comfortable, and then you can do more steps in your head without showing your work. But at the beginning, I really want you to show step by step which pieces you're combining and simplifying. Alright, let's do some practice problems. Again, I'm not going to do all these. Let's kind of pick and choose. Let's go diagonally like this, so that way we have lots of room. So I'll try to do all the ones that I've listed here. So 8 to the 8th over 8 to the 4th. When dividing two things with the same base, keep the base the same. So the 8, which is the base, stays the same. Subtract the exponents. 8 minus 4 is 4. So there's our answer. Next one. The numbers we keep the same. Okay, so 5/4, and it's negative. Okay, c squared divided by c squared. Now here, 2 minus 2 is 0, so those cancel out because they're identical. Then we have d to the third over d to the first. 3 minus 1 is 2, so this gives me d squared. Final answer. Okay, moving right along. Negative 4 divided by 24. Again, we do our numbers first. 4 over 24 reduces to negative 1/6. X squared, x to the, I think that's a 5. Okay, so there's two ways we could go here. We could use the division rule by saying x squared over x to the 5th is x to the negative third, and then negative 1 over 6. Because it has a negative exponent, we can move it to the denominator where it belongs with a positive exponent. Or we could have just right off the bat looked and said, okay, think of this as a battle. There are 2 x's here and 5 x's here, so clearly the bottom is going to win by 3, so the bottom has x to the third left over. So the preferred answer is to have the final answer with no negative exponents. So if you have a negative exponent, always move it to the other side. Notice here this is a negative number, a negative coefficient, which is not a negative exponent, so a negative coefficient is totally okay. Okay, how about over here? Here we've got 3 terms, 3 monomials multiplied together. So we can start off by either changing the negative ones by moving them to the denominator, or we can just combine like terms. So here I'm going to take the x and combine them together. X to the third times x to the negative 8th. Now these are multiplied, so I add the power. That's going to be x to the negative 5th, because 3 plus negative 8 is negative 5. Okay, the y, there's only 1, so it just stays the same. Okay, so there's my answer, x to the negative 5th times y to the negative 5th. But I should write that as 1 over x to the negative 5th needs to move into the bottom, and y to the negative 5th also needs to move into the bottom. And again, when you move them to the bottom, you change it from a negative to a positive. The act of moving it down is what changes the sign of the exponent. Number 14. So here we could distribute the negative 4 into the top and the bottom. So we have 4 to the negative 4th over 3 to the negative 4th. Okay, that's got a negative exponent, so it has to move into the bottom. 4 to the 4th. That part moved to the bottom, and the exponent became positive. And that part has a negative exponent, so it needs to move to the top. 3 to the 4th. So your final answer is 3 to the 4th over 4 to the 4th. Again, you could actually write out 3 to the 4th as a really large number and 4 to the 4th as a really large number. But in this case, exponential notation is totally okay to leave your answer in that form. Okay, last one. We've got all this nasty, complicated stuff, but it's to the 0 power. So in fact, that's really easy. It just equals 1. You don't have to do anything at all. So remember, divide your numerical coefficients just like normal. If they're negative, they stay negative. If they're positive, they stay positive. Then simplify your variables by using the exponent properties, either thinking of it as a battle where you have a combat and the winning side has more, or think of it as the just mathematical rule where you subtract the exponent at the bottom from the exponent at the top. And again, we'll do lots of examples in class with multiple variables as we go.